Hi, this is Group 14's video presentation for Project 4 in ME3210 Design and Manufacturing, taught by Dr. Hassan Rashidi. My name is Tyler Larsen, and my teammates Denny Vojdinkovich and Terry Cow will be presenting 10 selected research topics regarding various aspects of design and manufacturing. First, you will hear from Denny, followed by Terry, and I will close out the presentation after that. Thank you.
Hello, I'm Denny Vojdinkovich, and for my section of the slides, I talk a lot about methodology and kind of what goes into design. And to start that off, I'm starting on ergonomics and human factors. Giving a brief introduction into ergonomics and human factors, ergonomics is really just the study of how humans interact with the things that they design. And more specifically, how do you design a thing so that humans can use them well? When you're designing a chair, how do you make a chair comfortable? You're designing a phone, how do you make it so a phone is easy to use and easy to understand for any human? And ergonomics applies to basically any field of design because almost everything we're doing is used by humans. In terms of capabilities and limitations, it's kind of hard with ergonomics because ergonomics is a limitation fundamentally. It is the limitation of designing for humans and accounting for humans and their flaws and the fact that they aren't perfect beings. However, in terms of capabilities, ergonomics is really convenient because it makes things more efficient. The faster you can make someone use their phone, the easier it is for them to do stuff with their phone. In terms of applications, ergonomics is used in basically anything that would ever be used by a human. Chairs, prime example, any kind of software or coding, anything that's designed to be held in human hands or used by human hands. You need to account for how that human will use the thing, the perception of that human. How do they see this thing? How do they expect to be able to act with it? Can they actually act with it that way? Everything uses ergonomics. And in terms of how this makes products better, it's kind of, as I discussed before, it helps humans be more efficient by making things that are more convenient for humans to use, that aren't as clunky or more streamlined. We can get more stuff done in shorter amounts of time. Because this chair is nice and comfortable, I can sit on it for 6 hours and work on a project. If this was just a steel block that I had to sit on, I would have to stop way more frequently. Continuing to the next point of discussion, we have Mura, and Muri, which are the 3M principles behind Toyota's manufacturing philosophy. The idea behind the 3Ms is to minimize the inefficiency of resource allocation, with Mura being the concept of waste, or essentially using resources in ways where you could have gotten more out of them. Mura or inconsistency, the idea of like you want shipments to be as consistent as possible. You want to know exactly how much you're working with. And then muri or overload, which is the idea that you want to evenly distribute this stuff as much as possible so you don't put too much pressure on a specific aspect of your manufacturing. In terms of capabilities and limitations, the 3Ms are ultimately useful because they increase efficiency when it comes to manufacturing. The whole point is that the 3Ms are trying to optimize and make manufacturing things and delivering things as efficient as possible. However, in terms of limitations, it has to rely on consistency. And ultimately, there are always going to be external factors that cause things to be inconsistent. And the model doesn't necessarily have a space for inefficiency because the whole point is to get rid of it. In terms of applications, the 3Ms were initially conceived by Toyota and were used by them. However, the concept of the 3Ms has kind of broadened into the concept of lean manufacturing, which is used by a ton of industries to this day. Then, in terms of how it can make products better, ultimately the 3Ms don't really make an individual product better. It just makes creating products more efficient. If anything, it reduces the cost of things because now you don't have to deal with as much inconsistency when you are doing your best to remove all the inconsistencies in manufacturing. For my third topic, I'm working with minimal viable products. In terms of a summary for a minimum viable product, it's essentially just a product that is extremely simple and kind of just barely functional, that is designed to be quickly gotten out to any early adapters to see what they think of a product and if they see potential in it and would be interested in a more fleshed out version in the future. In terms of capabilities and limitations, the main benefit of a minimum viable product is it's a very cost-effective way to get validation from consumers. That you can throw out the product, you see if they like it. If they don't, scrap it, you lost whatever. If they do, you can continue to develop it. But in terms of limitations, it's difficult because it requires existing interest. You need to be a big enough company that you won't just sink because you threw out one bad product. In addition, you're also exposing yourself to your competitors. You're showing here's a new interesting technology, and if they see that other people are interested in that, they will also start to develop it as well. The primary application of minimal viable products is in software development, where it's incredibly easy to just throw an app to the market and go, okay, is anyone interested in this or does no one care? Other than that, it has been seen in some physical products, but ultimately it's a lot harder to do with a physical thing because it takes so much more investment to make a physical product compared to a digital one. And in terms of how it makes better products, MVPs are really useful because they give companies insight into what people are actually interested in. That they can go, cool, I have this idea. Does anyone actually care, or should I just focus my attention elsewhere? So if anything, it makes better products because it helps people who make things know what people are actually interested in, and they can put their focus into things that people will actually care about. And then for my last topic, I'll also be covering a little bit about product benchmarking. Now, the main point behind product benchmarking is really to analyze other competitors and see what other people are doing in the same product space, specifically by typically buying versions of competitors' products and then breaking them down and analyzing them in order to understand what they do better, what do they do worse, what are we missing that they have. The primary capability of product benchmarking is that it gives a lot of insight into the market. That as a product maker, I can look to my competitors and go, okay, who actually has the best product? Who has the worst product? Am I the best? If I'm not, how do I fix it? If I am the best, how do I keep fixing my things? What have other people done better? In terms of limitations, though, the big problem is that your data is limited. Your competitors are not going to give you all of their information. You're just going to have to scrounge up whatever you can from their products or from their press releases. Ultimately, product benchmarking is super important in any kind of space where there is a ton of competition and a ton of different companies. Specifically, hardware and any kind of computer application stuff, super prominent. But as a small anecdote, I do want to offer Tyler, my project mate, mentioned that he had a internship where he worked on like the product benchmarking team for a door company. Even doors need to compare to their competitors and see what other people are doing better and where to improve. Ultimately, benchmarking is useful for products because it helps competitors compare with each other and compete to make something better. It makes products better because these guys can see who is doing a better job and how do we make things that are better so that we can outperform our competitors.
Hi everyone, my name is Terry Cow. I'll be discussing three topics. Let's start with collaborative robots, or cobots. Cobots are designed to work alongside humans, enhancing productivity and safety in manufacturing environments. Unlike traditional robots confined to cages, cobots can share workspace with people thanks to their built-in sensors and advanced programming. Application of cobots would include assisting in assembly lines by performing repetitive tasks like screw fastening, conducting quality inspection to identify defects with precision, handling packaging and palletizing tasks efficiently. What makes cobots so important is their adaptability. They're perfect for industries with rapidly changing production needs, ensuring that businesses remain flexible and efficient. Their capabilities include being compact, highly flexible, and safe to operate. However, cobots do come with limitations, like higher upfront costs, limited speed and payload, and requiring skilled operators for setup. Next, let's dive in generative design. This is a design process that leverages AI-powered algorithms to explore multiple design solutions based on parameters like material, weight, and cost. Engineers simply input their constraints and the system generates a variety of optimized designs. Some of these applications include creating a lightweight yet strong component for aerospace and automotive industries, developing customized medical implants that perfectly fit patient needs, producing optimized consumer products with minimal material waste. The importance of generative design lies in its ability to push the boundaries of innovation. Engineers can rapidly iterate and test ideas quickly, significantly shortening the product's development cycle. Capabilities of this technology include rapid prototyping, integration with 3D printing, and creating designs that were previously impossible to achieve manually. However, it does have limitations such as high computational requirements, a learning curve for users, and the need for advanced manufacturing techniques to realize complex geometries. Let's talk about augmented reality, or AR for short. AR overlays digital information onto the physical world, transforming how we visualize, simulate, and interact with products and processes in manufacturing. Applications of AR are vast, visualizing virtual prototypes, providing real-time maintenance, training employees through immersive simulations, performing quality assurance and inspection by highlighting defects on physical parts. The importance of AR cannot be overstated. It bridges the digital and physical realms, allowing the team to collaborate and make informed decisions quickly. AR tools enhance efficiency, reduces error, and improve overall productivity. The capabilities of AR includes real-time visualization of CAD models, interactive training, and integration of IoT data for dynamic feedback. However, its limitation includes a high cost of hardware and software, reliance on a stable network connection, and concern over data security.
This is Tyler speaking again, and the last three topics of this presentation focus on the future of manufacturing. The next topic is Industry 4.0. Since the Industrial Revolution in the late 1700s, manufacturing companies have been integrating more and more advanced technologies into their processes. Today, Industry 4.0 is marked by the use of some of the newest technologies which bridge the physical and digital worlds in such a way that makes smart and autonomous systems possible, and more better than they've ever been before. These are the 9 technology pillars on which Industry 4.0 is built. Autonomous robots, simulation and digital twins, horizontal and vertical system integration, Internet of Things, cybersecurity, cloud computing, additive manufacturing, augmented reality, and big data and AI analytics. One limitation of all of these technologies is the level of skill required to operate each part. There will always be a need for human involvement, but some predict that these highly specialized systems may lead to labor shortages of skilled workers. To give a really cool application, Amazon leverages Industry 4.0 technologies in its supply chain management. They use IoT sensors in warehouses to monitor inventory, predictive maintenance is used for delivery vehicles and drones, and digital twins are used to optimize operational processes. And all of this has led to faster deliveries and reduced costs for Amazon. While Industry 4.0 is ushering in smart factories like Amazon's that are highly efficient, flexible, and interconnected, it is also helping manufacturers make the key shift toward data-driven decision-making. This approach is an extremely significant change in product design and manufacturing, probably the greatest shift there has ever been. The next selected research topic is the Industrial Internet of Things, also known as IIoT. In summary, IIoT is a large network of smart sensors and other devices which collect, exchange, and analyze data in order to enhance manufacturing processes. The data collected by these devices is used to make the overall manufacturing process more efficient and reliable, and integrated. With an IIoT system, real-time data can help predict when a machine needs to be serviced, which is a method called predictive maintenance. IIoT sensors can also be installed into the product itself, giving manufacturers more insight into the customer needs. And one limitation includes the difficulty of retrofitting older machines with IIoT capability, and also some sensors will eventually fail if they're installed in harsh environments, such as on vibrating machinery or near heat sources. Commercial jetliner maker Airbus launched what it calls the Factory of the Future, in which they integrated sensors into their machines and gave their employees industrial smart glasses in hopes of reducing errors and enhancing workplace safety. Also, a manufacturer, Fanuc, has used IIoT sensors in its robotics to predict the imminent failure of components in its robots. Doing so enables the plant manager to schedule maintenance at convenient times, reducing costs and decreasing downtime. It's the best of both worlds. So how can it help make better products? Well, going forward, IIoT devices will play a major role in the digital transformation of product lines and supply chains. They will become standard in factories as they help manufacturers upkeep their machines and produce better quality products. And now the final topic of this presentation is about digital twins. A digital twin is a virtual replica of a physical object, person, or process that can be used to simulate its behavior to better understand how it works in real life. So you have a physical copy and a digital copy, and they're twins of one another. Digital twins are capable of testing designs without building a physical model to save cost, identifying and improving bottleneck points to improve efficiency, and visualizing new products or projects in 3D space. And one large limitation is collecting and analyzing the vast amounts of data it actually takes to start implementing digital twins. An interesting application is in healthcare, where digital twins are used for patient-specific simulations and surgical planning. Doctors can actually use digital twins of their patients to better understand individual needs and even predict possible outcomes. Digital twin technology can be combined with other Industry 4.0 technologies to create very comprehensive manufacturing systems. In some cases, digital twins may also help manufacturers reduce waste, even up to 20%, as I saw in some of my research. And finally, here are all of the resources we used for this project. Thank you for listening, and thank you, Dr. Rashidi, for a great semester.